Hi everyone. In the last video we talked about pKa and how we could use that to quantify acid strength. This is going to be a quick intro video on how you can look at a pKa table and read it and then use it to your advantage. Now, my preface here is going to be if you know all of these pKa values, or at least the approximate pKa value, you will be thanking yourself later in this course, okay? pKa, pKa, pKa. So important, my friends. Okay. Now, what you can do to memorize the acidity of protons is think about the functional groups. And in the first part of our introductory video series, we talked about functional groups. It is very advantageous to relate protons' acidity to functional groups. For instance, the acidity of an alkane proton is kind of around 49, and your professor might give you a slightly different value, which is fine, but we could say in general, alkanes are around 49, 50, they're very weakly acidic. Remember, high pKa means low acid strength, weak acid. But something like a phenolic proton up here is around pKa 10. That is a lot more acidic than an alkane. And so as you look at this pKa table, you can actually talk yourself through the pKa table in this way. You could say that a carboxylic acid, like acetic acid, is more acidic than phenol. We could say a carboxylic acid, like acetic acid, is more acidic than an alcohol. And you can make a hierarchy of pKa understanding based upon functional groups. And I think that's really, really advantageous, okay? Now, later in this video series, we will be talking about the factors that affect acidity. And after we talk about those factors, this will make even more sense, right? You can make these comparisons between two acids looking at electronic factors or aspects of the atom like hybridization state and size and electronegativity to differentiate acidity. At the end of the day, though, sometimes it's hard to make a comparison just looking at the factors. And that's where pKa will come in, meaning you can use pKa values to more definitively make a statement, yes, I know this acid is more acidic than that acid because I know its pKa value. So I can't stress this enough, pKa, pKa, pKa. Now, the thing about pKa's is they will differ depending upon the resource that you look at. So if your professor is having you memorize specific pKa values, which they may very well do, know the values that your professor gives you, okay? These are kind of happy medium values that tend to be true for the majority of professors in organic chemistry. So these pKa values are accurate and they are a great happy medium, but note that your professor's values might differ a little bit, and that is okay. Again, you might have to know very specific values, but at the very least, you should know approximate values and use functional groups to create a hierarchy of understanding for acid strength. Okay, again, we could say a terminal alkyne is not quite as acidic as water, but a terminal alkyne is more acidic than some type of alkyl amine or ammonia, just as an example. Okay, so take some time, be humbled by the pKa's. pKa's are your best friend, and you will thank yourself later for really devoting some time to understanding pKa's. You can make flashcards if you're a flashcard person. You can also download this document from Rogue Chem and use it and put it in your notebook, use it. It is your best friend.